Okay, welcome everyone to the very first enrichment content course video for elementary statistics. I am Ismael Garcia. I will be helping you out throughout this course or class or whatever you want to call it, review thing. Here we'll be talking a lot about elementary statistics. And then this very first video will have an introduction to statistics, sampling, and data. Some professors just straight out skip this very first chapter. Most of them don't. They do ask for students to learn this. They cover it in class. They may also ask questions about this very first chapter in the homework, quizzes, or the tests as well. So, I will be covering just the basic ideas in this very first chapter. I won't cover everything because there's not enough time to do that. And without further ado, let's dive in. These are the four main points we'll see in this video. What is statistics? What is data? The levels of measurement, which actually is kind of tied closely to data. And last but not least, the types of sampling. So the very first topic here, what is statistics? The course itself is called Elementary Statistics. So it'd be a good idea to start off with defining statistics, don't you think? So here it is. Statistics itself is a science. Specifically, the science of planning studies and experiments and obtaining data. Later on, we'll define what data is. But once we have this data, we organize it, we summarize it, we present it, we analyze it, and then we interpret it. Once we do all of that, we draw conclusions from the data. Statistics is widely used in many different sciences and areas out there in the world, from the medical field to businesses, accounting, and whatnot. Statistics is my favorite math class. When I first took it in high school, for the first time I saw the real life applications of math. We weren't just graphing polynomials that someone came up with out of thin air. We weren't trying to find the missing side of a triangle for whatever reason. This is real stuff. That's what impressed me the most. So I don't expect everyone to love statistics as much as I do, but I do hope that you like this class just a little bit and that you can actually understand it. That's my main goal. So I'll be helping you with that. So in statistics, we got populations and we got samples. A population is basically the entire group of subjects that we are interested in. Say, for example, we're interested in college students. That would be our population. And we're interested in trying to find how many hours of sleep they're getting. So that way we can kind of see how their physical and mental health are doing or something like that. And your population can be anything. Like I said before, it's anything that you are interested in, right? Now, on the other side, a sample is a small piece, a small group that we take out of our population. Why do we do this, you may ask? Some populations are just so absurdly huge. There's no way we can take into consideration every single subject. For example, let's say stars. Let's say we're interested in all the stars in the observable universe and we want to find the average brightness of them. There are so many stars in the observable universe, there's no possible way we'll be able to count them all and measure them and include them in our research. It would be way too expensive, it would take so much time. So, then how can we even think about knowing what the average brightness of stars is? Well, we take a couple of stars, we select them in a specific way, And later on, we'll talk about sampling. There are some sampling methods that are better than others, but we get a little sample of stars, and like the definition of statistics said, we organize them, we analyze them, and then at the end, we draw conclusions from them. So sampling is a really huge help when it comes to obtaining this information that we're interested in. Now, from a population and from a sample, we can obtain special numbers, namely a parameter and a statistic, respectively. Both of these definitions are nearly identical. There's just one word that's different. So basically, a parameter is some special number that tells us some important information. Parameter is for a population. A statistic is for a sample. And underneath here, we've got a couple of different symbols. Don't be too scared about them. Here, these are just a couple of symbols that we'll commonly see throughout the course. We won't work with them right now. Don't worry. Don't be too scared. I just want you to be familiar with what they are and how they look like. Okay. On the parameter side, we have a capital N. That is for a population sample size, or I should say population. Yeah, it's kind of weird using population and sample in the same sentence. It's just the size of this group. Okay. Underneath that, we have a kind of like a U with a longer stick in the front. That's the Greek letter mu. It's kind of like an M in the Latin alphabet. That is a population mean. A lowercase p would be a population proportion. And that very last symbol there, it looks like an O with like a visor on its head. That is a population standard deviation. The letter is the Greek letter sigma, kind of like an S in the Latin alphabet. On the statistics part, we've got their respective symbols, but just for a sample. Lowercase n, that's a sample size. An X with the line on top, we pronounce that X bar. That's a sample mean. A lowercase p with like a party hat on its head, we call that p hat. That is a sample proportion. And last but not least, we have S and then a little X right underneath. That is a sample standard deviation. Something to note here, not all books include the little X on the standard deviation. I like to include it because I think it's really useful later on in the future chapters when we're working with different multiple samples and populations. The subscripts really help us identify what came from where. So just keep in mind, not all books include the X, they just write it as a lowercase s. I will include the X because I like it and I think it looks cool and it's useful. So there's that. Here I have a little diagram that hopefully helps you kind of identify what comes from where. So from a population, we can obtain a parameter. Remember that special number that tells us some important information. But from a population, we also get a sample, which is a smaller group from it. And then from the sample, we can find a statistic, a special number that tells us something interesting. And there's that. Last but not least, I was debating whether to include this topic or not. In the end, I decided to do so. Statistical significance, we achieve that when the probability of an event is 5% or lower. In chapter 4 is when we start working with probabilities. That's why I was debating whether to include this or not, because we're not working with probabilities right now. But just keep this idea in mind. Make a little note of it somewhere on the margin or whatever. We will be seeing this a lot. That 5% is special little value there. So don't worry too much about it right now in this instance. We will see it later on. Just we'll cover it a lot more throughout the course. Okay. So that was the very first topic. What is statistics? Now we move on to what is data. We've been talking a lot of data and organizing and making conclusions about this data, but what is it? It's fairly funny that such a big idea has such a tiny definition. So, data, it's defined as collections of observations. I like to think of data as just basically information. There is a lot of information surrounding us at all times, and we can obtain that information and just find a lot of interesting stuff about it. The very reason we use statistics is to, you know, collect all this data and find a lot of cool stuff about it. That's why statistics is here. That's why it exists. So now, data, it can be categorized into different categories. Well, yeah, that's in essence what categorizing means. But the two main ones here, qualitative versus quantitative. Qualitative data can also be called categorical data or attribute data. It basically consists of just names and labels. Say, for example, I ask you, what's your favorite color? You may like red, you may like green, you may like periwinkle. That's a nice color. But that's it. That's just your color, right? Your favorite color. We can't do any math with a color. It's just a name or a label. That's all that it tells us. Quantitative data, on the other hand, also called numerical data, it consists of numbers representing counts or measurements. So, like the very name itself says, it's numerical. It's numbers that we can work with, that we can do special kinds of math with. Now, what's really cool about quantitative data is that it can even be further broken down into discrete or continuous. Discrete data consists of values that we can count. 1, 2, 3, 4, so on and so forth. Whereas continuous data is data values that we can measure. And I got a couple of interesting pictures here about eggs. So you may be wondering what's up with the eggs? What do they have to do with statistics? Let's say, for example, that you're baking a cake, right? Just delicious chocolate cake or whatever pastry that you may love. And as you read the recipe, you find that it's asking for 2 eggs. So, what do? You go to the fridge, pop it open, you count the eggs, 1, 2, crack them open, toss them in the mix, and you're on your way to bake some delicious pastries, right? Now, just imagine for a moment that you're reading the recipe, but it calls for 1/4 of a cup of egg. How in the world are you going to obtain that half a cup of egg? You would have to use some kind of measuring tool, right? In this case, a measuring cup. And then you crack open some eggs until you have 1/4 of a cup. So that's the main difference. It's the same thing we're doing. We're still baking a cake, but on one side, we just count the number of eggs. And on the other side, we measure eggs until we have that desired amount. And it's really weird when recipes ask for milligrams of eggs or something really silly. I'm not sure why they do that. There may be some reason for it, but who knows? I just think it's kind of funny. Now, there's another way to think about discrete versus continuous. This is my favorite way, and I do want to share it with you guys. So just imagine a number line, right? 0, 1, 2, 3, 4. Discrete values can only be whole numbers. They can't be anything else. So it's just either 1, 2, 3, 4. That's it. Like, for example, if I ask you, hey, how many siblings do you have? Well, you'd have to count them, right? 1, 2, 3, 4. You can't have 2.5 siblings, right? They can't be decimals. It's got to be a whole number. Now, on the other hand, continuous values can also be whole numbers. If you measure the height of a tree, it could very much be 3 feet tall, exactly 3 feet tall. That could happen in nature. That's totally possible. But continuous values could also be fractions or decimals or percents or anything in between the whole numbers. So that tree you measure could be pi feet tall, 3.1415. Or it could be e feet tall, 2.781828, so on and so forth. It could be any value in between. Decimals, fractions, like I mentioned. So, and obviously this number line continues on forever on both sides. Like I mentioned, this is my favorite way of thinking about discrete and continuous. If you like this method to remember them, you can very much use it. Or if you prefer the bacon, the cake, and the eggs analogy, you can use that instead. Whatever works for you, go ahead and use it. And as a little summary here, data is information that we're interested in, that we can collect. It can be broken into qualitative, categorical, or quantitative, numerical. And numerical data can be broken further into discrete or continuous. This is another little flowchart here. Now, there is a second way that we can categorize data. And we can categorize it using the levels of measurement. So, the very first level of measurement here is nominal. And it just consists of names, labels, or categories. It's exactly the same as categorical data. Labels like your favorite color, red, blue, green. It's the same thing. But a little extra information is added here. It cannot be arranged in some order. So, say for example, I ask you, what's your favorite food? You may like pizza or hamburgers or anything, right? But now let's say I tell you, which is greater, pizza or hamburgers? That's a nonsensical question, right? There's not a specific order we can put them in. And if we're talking about preferences, that's subjective. That's opinions, right? Not objective, not hardcore science we're talking about. So that's basically what nominal is. Just categories or labels or names with no specific order. The next level of measurement, ordinal. This one can be arranged in a specific order. But the differences between the data values, in other words, the subtracting them, is either not possible or doesn't tell us anything useful. In the example here I have are letter grades. So obviously an A is better than a B, and a B is better than a C, better than a D, better than an F, right? But now let's say I tell you, what is A minus B? We can't really do that, right? Because it's just their letters. If we were talking about their percentages, like a 90% and an 80, then we could do some cool math with it. But just with their labels, we cannot subtract them. And if we can, then it's not really useful. Okay. So a really neat little trick you can do here. Ordinal has to do with order. So it's kind of in the name. It's hidden in the name. So just remember the ordinal values, it can be organized in a specific order. Now we get into some cooler stuff here. Interval values. these values can be arranged in a specific order, and the differences can be found, and they're actually useful. But there is no natural zero starting point. That means none. The picture here is an example. Think of temperature, either degrees Fahrenheit or Celsius. In both Fahrenheit and Celsius, we've got, the positive numbers, but there's also a zero, right? But that zero doesn't mean that we have no temperature, right? It's just kind of like a placeholder value. If we were talking about the Kelvin scale, then that zero does mean that we have no movement in the particles and atoms, right? We won't go too much into depth in that topic, but just keep in mind here, interval values doesn't have that baseline zero. That means none. And last but not least, we've got ratio. So this is like the pinnacle of data of the levels of measurement here. It's data that can be arranged in order. A difference can be found, and they're meaningful. And there is a natural kind of baseline zero. And the example that I've got here in the picture is money, right? If you've got $50 and then next week you have $100, then $100 is more than 50, right? You have more money than the previous week. You can also subtract them. You've got $50 more than the previous week. And there's that special zero that means none. If you have $0, that means that you have no money. That's the importance of that baseline zero. It has to be there. Also, because of that baseline zero, we can find some multiplication and division stuff as well. So there we go. That's a ratio. I got another little diagram here that kind of summarizes what we covered. So data can be organized into the levels of measurement. We got the nominal, we got the ordinal, we got the interval, and we got the ratio. The nominal tells us the least amount of information. Like we mentioned before, they're just labels or names. There's not a lot of stuff we could do with nominal data. And if we go further down, ratio gives us the most information. We can do a lot of cool stuff with ratio data values. And now we're on to our very last topic for this video, types of sampling. There's got to be a special way we obtain the data, this information that we're interested in. And here are some of the main basic ways of sampling or collecting that data. The very first way, we call it a simple random sample. You can also kind of shorthand it into SRS. I probably should have written it in the presentation, but I didn't, but whatever. The main idea here is we're randomly selecting subjects, right? So like I got the picture here in the presentation. It's like picking numbers out of a hat. But we're not picking them one by one. That would not be too appropriate because the probabilities of picking one number would change because you pick one, you keep it out. Now the probabilities are going to be all switched around. In chapter 4, we'll talk about the probabilities and independent versus dependent. But here in this specific definition here, we're not picking one by one. We're picking groups all at once. And this sample, the samples have to have the same probability as the definition mentions here. every possible sample of the same size must be the same probability. Okay. Picking numbers randomly using this method by hand is not recommended. Software is mostly used for this, so just keep that in mind. Computers to the rescue. Another kind of sampling is systematic. Basically, it consists of just randomly selecting a starting point, and then we choose every kth element. So like in the diagram, let's say we just randomly pick, okay, we're going to start at number 2. And we're going to sample every third person. So we count from 2. We go 1, 2, 3. On 5, we sample that person. And we count another 3. 1, 2, 3. We land on 8. We sample that person. 1, 2, 3. 11. We sample. So on and so forth until you have a very decent sample. And this is a pretty simple sampling method. Now we go into a little more intensive kind of sampling. And stratified. We basically have a population, and then we kind of separate them into different groups that we call strata. And all the subjects in the strata have some characteristic that is the same. And then from each individual strata, from each group, we randomly select a couple of subjects. It's kind of like I have in that little picture there. The population is all mixed around. Once we subdivide them into strata, and then we got all the little yellow subjects there, red subjects, and the purple subjects. And from each different colored strata, we randomly pick a couple of subjects, which is pretty neat. So that way we'll have representation from each of the individual groups. So this is a really good method. The next one has to do, or first thing I should say, it's called cluster sampling. It's a little similar to stratified. We do have our population and we are dividing them into groups. But here it has to do more with area, like actual geographic area. We divide this geographic area into different groups that we call clusters. And then we randomly select a couple of clusters. And those clusters that we select, we're actually going to sample every single subject within that cluster. So the main difference between stratified and cluster. Stratified, we're dividing the population into subgroups. And then we randomly select a couple from each subgroup. A cluster has to do mostly with geographical area. So we're actually dividing the land or an establishment or you name it. And once we choose a cluster, we're going to sample every single subject inside that cluster. So hopefully you can identify the main difference between those two. They are fairly similar, just different in a small way. Multi-stage sampling. It's basically a combination of 2 or more basic sampling methods. So you could start off with a little bit of cluster sampling, and then you got all your subjects, and then you can do some systematic sampling or a simple random sample. You're basically combining all of the main basic sampling methods together. This could take a lot more time, but I don't know, maybe it will be more useful. I haven't seen an actual real life application of this, at least not yet, but it'd be interesting to know why they go through all this trouble, right? And the very last kind of sampling that I want to talk about here is convenience sampling. Basically, you just collect data that is easy to get. Say, for example, kind of like an internet poll. They ask you, hey, you want to participate in this poll about whatever, politics or any other topic of interest. And then the user will voluntarily participate in the poll, right? This is not a very good way of obtaining data because it could lead to a lot of bias. For example, just think about who is going to participate in those polls. Only people that have strong opinions, either on one side of the spectrum or the other, are going to participate, right? So the data you obtain from a convenience type sample is going to be really skewed to one side or the other, or it's just not going to be, there's not going to be good representation of everyone, right? Other kinds of convenience sampling are kind of like telephone calls. Like, hey, you want to participate in this sample and tell us stuff? And other kinds of easy to reach ways, right? The best kind of sampling has to do with randomly selecting subjects in one way or another. Convenience has no randomization whatsoever. So if you are to collect data, make sure to use some kind of randomization. Okay. And that basically wraps up all of this very first chapter video kind of thing. So hopefully this was a little useful. And go ahead and take a break. This was a lot of information, so make sure to take ample breaks. And then next week we'll be covering a lot more cool stuff. All right. See you, everyone.